just so you know. And I'm going to be sharing our agenda first. So let's go there. Because I put some things on the agenda for you that I really want you to see. First of all, being today's schedule, although it's already fourth period, so you'll want to know where that is. So what we're going to do is we're going to wrap up chapter 5. I'm going to talk about chapter 5 first, and then I was going to do group work, but we won't have time. So I'm going to go over chapter 5, and I've already done all of the problems. So I'm going to show you where they are. And in a perfect world, we can at least talk through them. But I also wanted you to check your lowest, check your grade in Aries, please, because I dropped your lowest quiz yesterday. It helped most people between 2 and 3 points in their grade, actually. So you might be happy to report that. Please make sure if you have any issues with your grade or grading, or you turned in something late and forgot to tell me, I'd be happy to fix it, but please do so before your final. So if you go to the class notebook, again, you'll notice that under, I believe it's under content library, actually. Oh, okay, it's not. So here's the semester stuff, and here's the answers. So they're all in there, which is why I'm a little bit okay with not being able to solve every problem with you. Okay, but I'm going to show you under the camera how this all works, and we'll review these few ideas. Oh, here, I'm sorry. In the notebook, what I wanted to do was show you, was to go over the notes quickly. That's why I knew okay. So let's just start quick with section 1. All right, so section 1 of chapter 5. This should all be the freshest stuff to you because, right, it was the most recent. You can classify triangles by sides. No sides the same scaling, 2 sides the same isosceles, 3 sides the same equilateral. You can classify by their angles. If they're all less than 90, it's called acute. If you have at least one 90-degree angle, it's called right. If you have one angle that's greater than 90, it's called obtuse. And a special case is if all 3 are exactly the same, it's called equiangular. So then all you had to do was look at pictures and identify. This type of problem we did a number of times. You had to use the distance formula to find the length of each side and then classify it. Then we used the slopes of the lines to figure out if those were perpendicular and yes or no. So that is important. We had a number of those examples. You'll see it again. Second section, we also had the triangle sum theorem. And what that means is that angle A plus angle B plus angle C equals 180. I'm pretty sure most of you know that, so I'm skipping, I'm going quickly. We have a corollary to the triangle sum theorem, which means that if you have a right angle like C, then A plus B have to add up to 90 also. We have an exterior angles theorem next, which was actually my favorite. I love this theorem. It's very handy. What it means is one angle outside is equal to the sum of the 2 exterior that aren't attached to it. So here's what the exterior angle theorem says. See where it says 2x minus 5? That means that it's equal to x plus 70. This angle outside, the exterior one, is equal to the 2 on the inside that aren't attached to it. And then you could find this one by, if you have a 90 degree, then 2x plus x minus 6 has to add up to 90. So all these kinds of problems are pretty easy to use. We also talked about the third angles theorem, where if you have 2 triangles and they have 2 that are already congruent, then angle C has to also be congruent to angle F, because it's the only way you can get them to add up to be 180. And that's called the third angles theorem. That was section 1. Section 2. We had one super important idea, which was called corresponding parts of congruent triangles are congruent, where basically we figured out if you can use a rigid motion, which is a reflection, a translation, or a rotation, if you can take one figure and do that, one of those transformations or a combination of those transformations, then you can prove that they're congruent. So if you can take this first figure and rotate it or flip it or translate it somehow so that it exactly matches this, then you can prove they're congruent. And what that means is then you can write a congruence statement. If you can write a congruent statement, say this is equal to that, then you can solve problems like this, where stuff is equal to each other and you can solve for X or Y. It also has these three properties: reflexive, symmetric, and transitive. So plus there's an algebra review there. We didn't do that, so it's just this one page. The third part is where we were proving that triangles are congruent if we know that two of the sides are the same and the included angle, here it's A, is congruent to angle D. So the two sides that form the angle are the ones that have to be congruent. It can't be BC, it can't be EF. It has to be the sides that form that angle, which is why it's called included. If you can get those three things to be congruent, then this theorem says that the entire triangles are congruent. If the entire triangles are congruent, then all the parts, the corresponding parts, are also congruent. We did some theorems, we did some inspection where we were looking, well, hey, can we prove that these are congruent by side angle side? And so that was section 3. And then last, section 4, was where we were looking at isosceles and equilateral triangles, because they have this special theorem called the base angles theorem. And so if you have an isosceles, it's at least two sides are congruent. If two sides are congruent, then the angles opposite them are also congruent. So this is congruent to this, if this is congruent to that, and vice versa. You have the converse. If two base angles are congruent, then the sides opposite them are also congruent. And that's a very handy theorem that we're going to use to solve problems like these. We solved that in our notes. And then we made congruent statements like that. You have a corollary. If a triangle is equiangular, then it's also equilateral, and vice versa. If it's equilateral, it's also equiangular. So this is just a special case of the base angles theorem, and we did some problems, and we'll do a few more. So that's a quick recap of chapter 5. Sorry I went so quickly, but I don't want to run out of time. Any specific questions? Okay, so then what I did is from 66, which is from the beginning of chapter 5, is I did all of these pages already, and I'm going to go through them again quickly. And then you've got all the answers already in the answer key. So if I say something that doesn't make sense or you don't remember, write it down. Okay, here we go. If you classify the triangles by their measures, the big one is right, the little one is acute, and then this bigger one is obtuse, EFG, because this one's bigger than 90. This one has all different sides because you're looking at this one here, so it's scalene. For each of these, I used the triangle sum theorem, where you have to add this plus this plus this to equal 180. I solved for X. That's what the answer was, so I'm good there. This one said solve for just ABC. So I actually had to figure out other angles to figure out that it was 47, but it's right here, this plus this, and then it has to add up to 180. This one you could use the corollary, where if you have a right angle, this plus this has to add up to 90. Or you could use the triangle sum theorem and just subtract 90 plus 150.2 to get that third theorem. So C is 39.8. For this one, this is that exterior theorem I told you I love. So this one here has to add up to this and this, and this. So to find this one here, I just subtracted 60 from 111. 77. Same idea as this one, but now you have x's. So this angle plus this angle, these two have to add up to 68. So I added them together as 7x, 3x plus 4x, and I got this. Now I solved and got x equals 9. But remember, you always want to answer what's being asked. So if you put in 9, you'll get it wrong. Even though you had the correct equation and you solved it correctly, you didn't answer the question being asked. So I still, to find D, I have to go back to here and plug in that x equals 9, and I get an answer of 41. That's why 41 is boxed. For 78, same thing. I've got two problems. They're both marked differently, but it says find the measure of the angles. And to write an equation, since these are the same and these are the same, the third angle theorem says these are the same. So I wrote an equation, 6x plus 10 equals 7x minus 2. I solved for x, and then I plugged it into both, and I got 82. Unfortunately, I did the hole punch to put it in my binder after that, but I got 82 for both of those. So any questions? Just checking to see if I have any questions or hands raised. Okay. Now we're moving on to the next one up here, 79. Again, I have two triangles that are congruent, and I set 3x equal 2x plus 11. Then once I got x equals 11, I plugged them in, and I both got 33. One thing specifically about number 80 I wanted to point out. There's no picture with number 80. All it says is you have xyz congruent to npq. When you identify the corresponding parts, all you have to do is look in the same order. So see how Z is the third one there? Well, it's going to correspond to the third one in the other one. So that's why it's Q. So Z is in the third place, Q is in the third place. For P, see how it's in the middle? That corresponds to angle Y. Y is in the middle. Angle X is the first one in the row, the first one in order. Therefore, it corresponds to angle N because N is the first one. You could do the same thing with segments here. So NQ is like the first and the last here, which means it's going to correspond to the first and the last in the other triangle, XZ. If I look at YZ, YZ is the last two here. So it's going to correspond to the last two here. That's why it's PQ. And then PN, you can even do it backwards. Look, PN is the middle to the front. So then I do the middle to the front, YX. Just remember, you don't have to have a picture. Order matters. Now, for 81. We're making good time. We may even be able to get through all of them. This would be great. Okay, so for 81, you're given that these two are congruent. Find x and y. So I had to write two different equations, which is also okay. But I have to make sure that it's the right corresponding part. So if I had a whiteboard, I would just redraw this one so that it's rotated in the same direction. Otherwise, if I wanted to solve for Z, I know that these two are corresponding. Those two are going to be equal. I know that this one corresponds to this one here. That's 90 degrees. So I wrote 4x plus 6 equals 90, and I solved for x. And then this other small angle here is congruent to this one here, because if they were in the same direction, they would correspond. So I wrote 5y minus 2 equals 28, and I got y equals 6. Again, if you have a question, unmute yourself or pop your hand up. Okay, now 82. You don't have any blank proofs on your exam, okay? So it will be something like this, where you're given specific reasons and you're going to have to fill in, or you'll have a choice where you just drag it up there, right? Because it is in big ideas. So on the one hand, you're stuck doing exactly the way I want you to do it. And on the other hand, you might have done it differently. Like for instance, in this proof, they have given, given, given. That's 3 different steps. But if I were writing it out, I would probably put all of them on the first line and just say given once. So that's something you'll have to figure out. Oh, it's frozen. Okay. So when you look through each step, you look at what they're telling you, and then you look at the picture and notice that it's these 2 angles they're talking about. Oh, that's vertical angles. Okay. And then if you have these 2 and these 2, then you can say that angle N is congruent to angle S by the third angle theorem. The third angles theorem. We know that this is the midpoint. So the next thing you'll see, definition of midpoint, means that I can say that PQ is congruent to PR. Then they go to the next one, and definition of congruent triangles, because at this point you've shown that all 3 sides are congruent and you've shown that all 3 angles are congruent. So there's not as much practice on proofs as we could have given, but here's another one. This is called a flow proof. Hopefully you remember, and I color coded it a little bit. Let's see if this will turn on the colors a little better. Yeah. Okay, so basically this is where you write it out. You could do it like this, but the other way we did was paragraph or flow proof. So I said, well, use SAS to explain why these 2 things are congruent. Well, I started with the green one, because I told you always start with connected stuff. Okay, this line right here is in both triangles. So WY is congruent to WY by the reflexive property, and this angle is congruent to this angle given, and this segment is congruent to this segment given. Therefore, 2 sets of corresponding sides and their included angles are congruent, so the triangles are congruent by SAS. There you go. I just like wrote it all out in a couple of sentences. And that is how you do a paragraph proof. So for instance, one thing I could do is give you this and then ask you to create this. That wouldn't be that hard, right? You would do given, given, you would do reflexive, and then you could say SAS. That'd be 4 steps. Hopefully that color helps you. Any questions? Okay, because I got to turn the page. Really unfortunate. Because we have 2 more pages. I'm trying to get through all of them. Okay, so here's the thing. 84, I'm going to skip for now just because, number 1, it's in the answer key already. And number 2, I'd really rather get to all these problems down here. These are there's going to be more of these. This one, it's in the answer key as well, but we never did hypotenuse leg. So just don't bother with 85 if you haven't done it yet. It's not on the test, it's for after. We'll get to that in the second part of chapter 5. What's super important is you need to be able to write equations, because there's a lot of these. Okay, so this is why I wanted to get to these. So for each one of these, you know different theorems. You just have to figure out which one applies, right? So just find the measure of angle C. Well, I'm given that these 2 sides are the same. So that tells me that these 2 angles are the same. If I know this angle, then, and all 3 add up to 180, this is the work I did. 180 minus 78, it gave me 102. These two have to add up to 102, and I know they're the same. So I divided by 2, and I got 51. But see, I didn't write an equation. I just figured it out, and a bunch of you were able to do that too. You could have written an equation, 2x plus 78 equals 180. That would work. Whatever works for you, but I always like to do my theorems. So again, this one is the same. It gave me isosceles legs, which means that this angle is equal to this angle. So I wrote 8x equals 6x plus 18. Solved both sides for x equals 9. And then I'm not done. I got to actually, again, go back to find h. So I still have to go back in and plug in 9 to get 72. So that's why this is boxed. If you put in 9, you will get it wrong. Just be careful. Take your time. You're only going to have, you'll have 120 minutes for a 35 question problem, 35 question test. Okay, 120 minutes. You'll have plenty of time. And so write stuff down so you'll know to be able to go and check your work too. Now this one, see how there's 3 tick marks? That means that they're all 60 degrees because that's the only way you can have all 3 sides. It's equiangular. And so I wrote, since it only gave me this one angle, 2x minus 6 equals 60. I got x equals 33, and that is what it asked for, so I can be done. X equals 33. 89, it's also equiangular, which means that these sides are all the same too. If the sides are all the same, I wrote y plus 10 equals 4y plus 1, and I got y equals 3. But again, didn't say find y, said find mn. So I still had to go back to mn, plug my y equals 3 into here, and I got 13. That's why that's boxed. That's why 13 is the answer, not 3. So as you're going through checking your work and you go through the answer key, make sure that you're checking the answer, not just what you got, right? Because you may have y equals 3 and think you're wrong. Well, you weren't wrong. You just didn't answer the question. Okay, so be careful with that. Holy cow. I'm so cold. Okay, good. We have time. Number 90, there's a couple of questions that I really wanted to make sure that you could answer. So this is sort of a throwback to chapter 2, but it's because they're definitions, but there's the equations are what I really wanted to see from you. So it doesn't say, it says to name the postulate. I didn't, but we'll talk about it in a second. So if I have this angle, I got a measure of angle 9, it's this, and angle 10 is this. These angles form a linear pair. So you need to know the definition of linear pair. That means they create a straight line. So if they create a straight line, they have to equal 180. That's the definition of linear pair. So I took this part and I added it to this other angle and I made it equal to 180. So then once you simplify, that's 4x minus 12, add 12 to both sides, I got x equals 48. And then, like it says, find the measure of each numbered angle. So I took the 48, I put it back into here for 3x plus 12, got 156. And I put it back into here for measure of angle 10, and I got 24. And if you'll notice, 156 plus 24 gives me 180. Yay, I know I'm right. That's why I earned the happy face there. For the next one, I've got vertical angles. And I know that vertical angles are congruent. So I was able to set 2x plus 23 equal to 5x minus 112. And then you take away 2x from both sides, take away 20, or I added 112 to both sides. I got x equals 45. Again, not the answer, but now I can plug this in. So for measure of angle 3, I plugged in the 45 here. I got 113. For number 4, I plugged in the 45 here, and I got what, 13. And again, I'm giving myself a smile, even bigger smiley face, because those are vertical angles. Okay, now there's a number of these where you just have to look at a picture and say, is that enough? Is it not enough? Is it true? You know, you should be able to figure this one out. So 91, we've got this plane is going up, this is plane L, and this one is coming like out toward us. This is plane K. Use the figure to determine. So plane L and K intersect at PS. Yes, there's line PS. That is the intersection. Points U, M, and O are coplanar. U, M, O. They're all in this plane. Yes, I can tell they're in the plane. Angle QOP is a right angle. Okay, QOP is a right angle. It is marked. Yes, there's the no. But now this one, says MQ is in plane L. M is here, and it continues through this line through Q, but once it goes this way, you can't say that it's in plane L anymore. So that's a no. And then PS, and MQ intersect at point O. Yeah. So that's just a matter of looking at it and being careful with it. This one in particular, chapter 4, I really wanted to go over this because it was like we spent one day on it, and it's a super useful theorem, and you can definitely count on seeing it in on the final. Okay. From whenever you have a reflection, and this works for both reflections and rotations. If you reflect it, Jimmy, 3 minutes. If you have an object like CDE and you reflect it across a line like A, then it's going to be the same distance from A on both sides. So it says CDE is reflected in a line to create C prime, D prime, E prime. Then this triangle is reflected in another line to create C double prime, D double prime, E double prime. Well, again, once you flip it over, E is going to be the same distance to D to B as B is to E prime. So it tells me the distance from E to E prime is 10. So I mark that blue line as 10. That means each one of these is 5. Maybe I'll even mark it. 5, 5. And then it says from E prime to B, that's why I did it in red, is 16. So then I added this one to go to E double prime to give me 16. So they're all balanced now. 5 to 5, 16 to 16. And it says, what is the distance between the two lines? So line A is here, line B is here, this part is 5 and this part is 16. That's 21. The theorem says if you flip it over twice, then it will be twice this distance. Okay, so you could either count 16 plus 16 plus 10, that would give you 42, or you can remember the theorem, it's twice 21 if you reflect it twice. Same thing with the rotation, it'll be twice the degree measurement. Okay, so if you have something here and you rotate it once and then you rotate it again, it'll be twice the degree measurement from the beginning, you know, between the angles. And that was an important theorem that I wanted to make sure that we got through. So you do have the answer key. We were able to at least get all the way through to the end of the packet. Don't Don't worry about what they say on the things. Just make sure that you attach all 92 problems by the time you take the test, which will be Thursday for you. So make sure that everything is attached, okay, in your teams. And if you have any questions between now and then, chat, check the answers, do whatever you can, and let me know how to help you the best.